Hey everyone, welcome to today's episode of the Cyberman Show. Today's topic is understanding the AI threat landscape. Now, I know that most of you are using some app that has a capability on AI, or you work for an organization that is testing waters with AI. In a recent survey that Gartner did, the survey is called CIO and Tech Exec Survey. The 73% of the respondents to the survey said that they have increased funding for AI. What that means is eventually enterprises will have AI embed in most of their platforms. They will use this for productivity or other use cases. Now, to look at AI from the threat landscape perspective, it's essential for us to understand how AI landscape looks like. For that, I was able to find a very interesting document created by Bessemer Venture Partners. This is the AI infrastructure market map. Essentially, it's data plus AI, but it's important to understand how the AI architectures are used by organization, and once you understand the architecture, you can think about the threat landscape and security controls around it. So, in the AI infrastructure landscape, the most basic component is the compute, which is essentially the hardware. These are chips like NVIDIA, AMD, Google, and then GPU as a service. You have other systems that are based on next gen distributed compute. And then on the next layer, you have the foundation models. This includes the LLMs and transformers, novel model architectures, multimodal architectures, image specific models, video specific models, etc. And of course, you have communities like uh, Hugging Face that are model hubs. The next layer is data and storage. That could include databases, it could include querying engines, it could include data transformation, curation engines, it can also include retrieval, post processing and augmentation components, analytics and output generation. And it's a large landscape. It's not essential for us right now to cover all the components in details, but what I'm trying to convey here is how the AI infrastructure is layered. So it starts with compute, models, data and storage, and then of course the model development and training, which could include orchestration, prompt management platforms, AI testing and eval platforms, model deployment and optimization platforms, and then of course the observability part, the model validation and monitoring part, and of course security. Right. So the most basic thing that any company will do if they're adopting AI or enabling AI based apps is compute, the models, storage, and of course the model development and training part. Right, these are the most common things, and there are various companies that are in this. Again, no association with anyone. This is merely a result of my search. Now, so these are the components in an AI architecture. Now, if I have to summarize it, this is all about apps that will have AI capability. This could include the artifacts of the app itself. With that includes the original source code, libraries, their dependencies, automation templates, build files, script, configuration files, etc. The second component could be workload, which is virtual machines, containers, serverless, deployment packages, and then, of course, the entire pipeline that's needed for this app to be created. The second component is data, and third critical component is AI models. So, app, data, and AI models are the three critical components in an AI architecture. That's very important for you to remember. And based on that, we can start talking about the threats. So threats can be categorized into various subcategories. Starting with shadow AI, this is essentially use of unapproved AI services, unapproved models, unapproved data sets, unapproved AI libraries, tools, code of or anything similar in the AI pipeline. The second category of threat could be threats specific to data. Now, this can include the poisoning of the training data, which is all about injecting incorrect or malicious data into training sets to alter the behavior of the model. The second one could be unintended bias. This is all about understanding bias in the training data that can lead to an AI model making unfair or discriminatory decision. Example, hiring a model trained on biased data might unfairly favor or disadvantage certain genders or ethnicities. The third threat on the data side could be data privacy violations. So AI models trained on personal sensitive data can violate privacy laws if they inadvertently expose or use this private information. In next thing around data could be data tampering or manipulation, which is attackers trying to modify or manipulate the data used for AI training or inference, leading to incorrect or harmful outputs. Next thing on data side could be malicious data injection, which is attackers injecting malicious data during the model's inference phase, causing incorrect outputs. And of course, data exposure and exfiltration are uh, some of the things that are specifically threats to the data. Now let's talk about the threats specific to models. This could include adversarial attacks, example creating uh, prompt injection. So essentially that means is somebody creates subtle changes in input data like prompts uh, to trick the model into generating incorrect or harmful responses. And prompt injection, specifically in this case, means that malicious users modify input prompts to alter the behavior of the LLM and make it perform unintended action. The second threat to the model could be over reliance or excessive agencies or permissions beyond what the model needs. The third threat on model could be model DOS, model denial of service. Essentially, attackers can overload or disrupt the AI system by targeting its data pipeline or model inference, making it unavailable or unusable. Model theft, attackers replicating or stealing an AI model by querying it multiple times and using its responses to build a similar model. Model drift, change in the model's performance, essentially a degradation due to evolving input patterns. Now, we've so far covered threats to the app, threats to the data, threats to the model, and then of course the infrastructure specific threats. So going back to the VMs, containers, serverless, the standard infrastructure threats that exist on these workloads. You also have supply chain attacks. This is where attackers can compromise third party data sources, pre-trained models, or software dependencies that are integrated into the AI pipeline. Um, Example, an attacker can inject malware into a widely used data set or library, affecting multiple AI models that rely on it. And if some of you recall, there have been instances where popular public platforms like PyPy, in fact, or Hugging Face also, they detected multiple attempts of malicious code getting uploaded into these communities or these libraries uh, with the same intent, supply chain attack. Okay, now let's take a example of an attack. Now this is an attack called LLM jacking. uh, LLM jacking essentially involves stealing and selling cloud account credentials to enable malicious access to the enterprise LLMs, while the victim unknowingly covers the consumption costs. So what the cyber criminal can do is they can get access to an infrastructure that has active LLM services, and the initial access can be done by exploiting a popular vulnerability, um, something like a Laravel app. The cyber criminal can exploit the vulnerability there. They can then discover the AWS credential, assuming this is on the AWS service, and then discover the AI services that are activated there and sell these at a cost. And the end user who's paying for this service from AWS doesn't come to know. So this is common, and essentially this leads to increased consumption costs for the end user of that AWS service on which this was hosted. So this is an example. Now, all these threads, they're not the full list. This is what I've found so far, and I'm sure there's a bigger list that we can find, and we'll learn more as these industries starts to use more AI based apps. This is just not an exhaustive list for sure. Now the other way to look at threats is by categorizing them into threats during development of AI based applications, threats when the apps are deployed in the production, and threats when the app is used. So example, prompt injection can be categorized into threats when the app is used. Okay. Threats during development of AI based. I just give you an example when of a supply chain attack where a developer can unknowingly download a malicious package, vulnerable package from a popular Python repository, and that can lead for that can lead to the compromise of this infrastructure. Okay, so it depends on how you want to learn, how you want to categorize. The threats are increasing, and they will increase as attackers, cyber criminals, and developers all across the world learn more about the AI based infrastructure, AI based development. Okay, so that's it. Also, I'm very thankful for the reference documents that I've found. So one is the AI risk management framework, also known as NIST AI 600 document, as well as OWASP top 10 for LLMs. Now the OWASP top 10 for LLM definitely deserves a dedicated session, so I'm gonna put that out. You will also find notes, detailed notes around this component, around these topics on my blog. So I'm gonna write the blog before I publish the podcast. Thank you so much for listening. Please share this podcast, its episodes on YouTube, Spotify, Apple, wherever you like to watch it. Of course, I'm going to upload the mind map to my shared drive, and I'll see you next time. Bye bye.